The crank and cam sensor fall within a category of sensors called speed sensors. This type of speed position sensor is actually tested depending on the actual build of the sensor. In this particular case, we are testing a magnetic sensor which is always composed of two leads, the actual ground and the signal lead. This sensor actually produces its own energy and is simply tested using a voltometer, graphing multimeter, or an oscilloscope, and you simply probe across it and you determine the actual signal output, such as amplitude and frequency. The actual testing of these sensors involves testing for actual signal output as well as any possible bias voltage outputted by the actual ECM or module to which this sensor is connected to. Cam and crank sensors produce a varying AC output with the actual amplitude varying according to the speed of the reluctor. The faster the reluctor, the higher the actual amplitude. This is another example of the principle of induction in which a current is induced inside the sensor by the actual reluctor. The actual testing of the bias voltage produced by the actual module to which the sensor is connected to, it's tested with the sensor disconnected. The bias voltage is nothing more than a voltage, very low current voltage between 3 and 7 volts that the actual module outputs through the actual signal line in order to determine if there are any shorts or open circuits. Again, the reluctor is the one that actually induces the actual magnetic field or current into the actual magnetic sensor itself. The gap between the actual reluctor and the sensor is very, very important when it comes to magnetic sensors. The gap is also important when it comes to Hall effect sensors, but however, this gap will determine the actual amplitude of the signal that's produced. If the amplitude is too low, it would not be, the signal will not be recognized by the actual module to which the sensor is attached to. Again, the faster the reluctor speed, the higher the actual amplitude of the sensor it's going to be. And of course, the faster the reluctor speed, the higher the frequency as well. Hall effect sensors on the other side are 3 lead sensors, and you test them by simply probing between ground and the 12 volt lead that feeds the sensor's internal transistor. An internal transistor is actually provided inside the actual sensor itself, which is the one that actually does the toggling of the signal line. The 3 basic steps for testing the sensor is by testing the 12 volt feed line, then testing the actual sensor ground, and finally testing the actual signal output. Remember that these type of Hall effect sensors always produce a square wave output, which has a specific set amplitude and a varying frequency. By simply probing between chassis ground and the 12 volt line, you can immediately ascertain whether you have a viable 12 volt power supply signal or actually voltage supply going into the actual sensor. This sensor also needs a stable and reliable ground, and by simply probing between voltage supply line or battery positive and the actual sensor ground, you can immediately determine whether you actually have a viable ground to the sensor. And finally, the last step is to actually test for the actual signal. Remember that these Hall effect sensors produce a square wave output. The square wave output, it's not affected as far as the amplitude is not affected by the speed of the reluctor. The speed of the reluctor will simply toggle on and off or make the sensor actual internal transistor toggle the signal reference voltage toggle on and off. This is how these sensors actually do their actual signaling. They simply toggle the reference voltage outputted by the actual computer through the signal line. They toggle that signal to ground, and hence you actually see a square wave output.